Greetings everyone. Welcome to Trigonometry for students and surveyors. We're up to lesson 4 now. Just give you a heads up here on the very first video I did. It went way too long, so I had to cut it down. So there's some content that was probably got cut out and was hopefully picked it up on the second, third one. We're not on the fourth one now. I'll make sure we get all the details covered though. So wanted to let you know on the free download 42S, which I've showed you guys in the past videos, there's when you hit store, there's a registry that comes up. You can store any key you want. You just always got to hit enter after you store something, and then when you recall something, you got to hit enter again to get it back out, which is different than this. You just hit store, the HP35S, you store it, and you recall it. So there's an extra keystroke in that, no big deal, works good. You also want to know that in the free 42S, there's an alphabet store system too. So you'd have to just play with that a little bit when you hit store, and ABCD will come up and you'll store it as one of those, hit enter. Later on you can recall one of them. When you go to recall, it'll bring that alphabet up, and it'll take the alphabet, it'll thin them out, it'll purge them out and just keep the registers. So you might want to store something, angle A as in A, something like that, so it'll be easy to find. Angle C as C. You might want to just store something else that's easy to remember in a certain alphabet. So you'll go in there, and those will stack so that the whole alphabet doesn't completely show up once you're doing your recall. Okay. So that's that. So just get familiar with the 42S, and then we'll go back to these here, and we'll do some formulas over here. This is our 3, 4, 5 triangle. That's the one you can remember that one real easy. 3, 4, 5, a squared, b squared, c squared. That's what it amounts to. We went through that already, so I won't go through that again. What I want to do is go through a couple areas that might trip you up when you're doing your trigonometry and you're going, wow, that's not what I was thinking. Remember that a squared, or a and b, this is the opposite, and this is the adjacent to what? Well, adjacent to the vertex of the angle, and this is the angle we're referring to right here. In this case, A. So it's whatever is opposite of this angle. This is the angle. So let's go through a couple things. So it's the tangent function. I had those all broken down and exploded out. The tangent function is opposite, the opposite over the adjacent. So that's 3 over 4. So we're going to do that real quick. 3 divided by 4. In this case, 304 divide. And you got that ratio 0.75. Then we're going to go arc tangent. 36, 86, 99. Okay, so we have that. All right, now, if you added that plus 90 degrees, subtracted from 180, you would get the angle B. The other way you can do that is if you're looking at angle B, you would go 4, enter, 3, divide, or 4 divided by 3. And that ratio is 1.33. That means this one is the opposite, is 1.33 times longer than that one. And then I also showed you the show on there. If you use show here, it'll show 33333. Okay. The way show works, if you just hit the orange key in show and let go, it'll stay there for a few seconds and go away. If you hold it, it'll stay for a while. Okay, so we have that 1.333 ratio. You don't hit these white ones yet. You don't hit the big ones yet. You hit the arc cosine. Or arc tangent, sorry, we're using tangent, arc, tangent. And this is 531301. I might as well write that in there. And this is the digital. 531301. Sorry, that should be a decimal because that's a decimal angle. That's the HR, not the other one. Okay, so that's fine. If you add those together, let's just do that real quick since we got that. Enter. You add that and that and that, you're going to get 180. If you add that, this is a 90 degrees. But that's really, we went through all that. I don't want to go through that again. Now let's go to where you can get confused. So let's say you have the angle and you have this side. You don't know what this side is. Let's say you have an odd shaped triangle. You don't know what this is. So the way these work is they got to go, if you're trying to figure out this cosine, you got to be able to do it through either the tangent, because these two go together, or through the sine, the cosine, because these two go together, not through the sine. The sine is 3 over 5. This was 4 over 5. This is B over C. Okay. So what you're going to do is you're going to bring in your angle. We call 0. I don't guess I saved that. Let me enter. That's what my problem was. 3, enter, 4, 5, 7, 5, arc, tangent. Now let me store that as 0. I like to store the angles at 0 because 0 looks like theta, and theta is a Greek symbol for angle. All right, so you have that. So now you don't know what this. So you come up to a triangle and you have the angle. Okay, one more time I will say this before you. For a right triangle, you need 2 sides is all you need, or you need 1 side and 1 angle. So you're trying to figure out 4. And you have this angle, and you don't know what 4 is. So you're going to bring that up, recall 0, there's that 36, 86, 99, and you're going to hit tangent, because you're going to use this one, and you're looking for this one. And you could use the cosine, the cotangent, or the cosine, or the cosine, to get that as well. But you're going to bring that angle up first. Now you're going to hit tangent, and you remember that was 0.750, that's the ratio. But that won't work because this is, obviously this is longer. This is why it's nice to have a 3, 4, 5 triangle that you can practice with. So you have that 3, 4, 5 triangle, well that's not going to work. So what you do, it's pretty obvious, you do the inverse function of that. And what I like to do, my preference is to hit 1x. And there's that 1.333 again. Now you're going to hit 3 and times, and we're going to get 4. That's how we did that. The other way to do that is, the reason I like to use 1x rather than divide, I think the other way to do that, let's try that. Let's go 3, enter, recall the angle, and now hit tangent, and go divide, and that's 4. The trouble is, if you I just like to use 1x instead of using 3, because then you got to put the side in before you put the angle. The other way, you put everything in at the same time, or you always put the angle in first when you're going from angle to the ratio. So the angles and the ratios are just inverse from each other. So that's why I like to use 1x. All right. Now let me show you something else. So let's go. So we have 4 over 5 is the cosine. All right, so we're just going to go 4, enter, 5, divide. That's the ratio is 0.80. Now we're going to hit arc cosine, and we got 36, 86, 99. So let's try to do that in reverse, because here we did it in reverse, and we got that. So let's try to do it in the reverse. Let's go 5 divided by 4. And that's 1.25. Now let's try to find the arc cosine on that. Arc cosine, invalid data. You can't do it that, because to get the sine, it's the opposite over the, to get the cosine, it's the adjacent over the hypotenuse, not the hypotenuse over the adjacent. And then same with the sine. Let's try the sine. Let's go 5, enter, clear up. 5 divided by 3, yeah, 5, enter, 3, divide, 1.667. So let's try to get an angle out of that. So we're going to go arc sine, and invalid data. Okay, now let's go 3 and 4. Let's go 4. This time we're going to do the long side divided by 3. We'll go 4, enter, 3, divide, 1.33. We did that already. Now we're going to go arc tangent. 53, 1301. That's how we got that. I believe that's called the cotangent. So you can do it with the tangent. You can't do it with either sine. So Now let's go to here again. Now let's say you have, well, let's leave the 5 up there for now. So this is the hypotenuse. Now we're going to recall our angle, 0, 3686.99. That's our decimal angle, or our HR, right here. That's our decimal angle. That's the way it's written. Now we're going to try to get 4. So we're going to, let's use the cosine. So 5, we're going to take the angle, enter, and we're going to go cosine. That's that ratio, 0.80. We already know that's not going to work because the hypotenuse is always longer than the adjacent or the opposite. The hypotenuse is always the longest side of a triangle, has to be. So that's not going to work, 0.80. That's going, if you multiply 4, it would work, or 5 times 4. Because we're looking for 5, we're not looking for 4, we're looking for 5. That's our missing one. So we have our, and then we're going to go 1x, that's 1.25 now times. Oh, that didn't work. Let's start all over again. Recall 0, 3686.99. And we're going to go cosine, that's 0.80. Now we're going to inverse that, 1.25, 4 times, and that's 5. Okay, so that's how you do it in reverse. Then the other way, like I said, it would be, if you didn't want to use the 1x, just inverts them from a division to a multiplication. The other way to do that would be 4, enter, recall your angle, and then cosine, and then divide, and that's 5. It works the same way. Whatever you're comfortable with. I like to hit 1x because I'm always multiplying, not dividing. And I can always enter my angle, distance in the same order every time. So try it both ways, whatever you seem to like. That's good. We'll do the same thing now with the 3. 3 and 5. We're trying to find 5 here. We don't know what it is, but we do have that angle. So let's recall that angle, 0, 3686.99. And now we're going to go cosine. Or now we're going to go sine because it's the opposite over the hypotenuse. The sine of that is 0.600. That's the ratio. This is 0.600 as long as that one. Now we're going to go 1x. Now we're going to go 3 times 5. So I think with yesterday and today, now you can solve pretty much. And you can always check it by going a squared, b squared, c squared. Well, now that's how you check your distances. Your angles, you check those by adding it up. And they should all sum to 180. And this is always a 90. That symbol is a 90. That's what that means, that's a 90. Okay, now over to this one. Now this is, that's the primer on that. Now this is where you could really get messed up. This is why you need a pretty good calculator. Okay, these two sides, this one is 140, see, a 3, 4, 5 is easy to see, and it's something that you use over and over while you're learning, so it's easy to figure it out. Okay, well that should be 3, that should be 5, that should be 4, why isn't it? So I'll rework my problem until I get what I'm looking for. But what happens if you have something like this, 142.0, 142.001? You could even, and I remember we talked about fixing our calculators to 4 places right of the decimal. I even worked this out with 0001, 1/10,000th of the difference of that. All right, so let's figure this out now. Let's go 142.001, 42.001, enter, 142, divide. Now I've got a 1 ratio. 1.0000 ratio. Well, that can't be right because a 100%, a 1.000 ratio means that it's the exact same length. Well, it's not. It's 1/10,000th left, tenths, hundredths, thousandths. It's 1/1000th over on this one. Well, it's 1/1000th of a foot. We'll say we're using U.S. survey feet. So why does it say 1? Well, this is where you need to go in your calculator and look at show. So I'm going to go show, And now it's 1,000, way over there now, 704,225. That's the decimal version of it. So now we're going to go 1. So if we just entered 1 and hit arc tangent, let's see, what are we looking at? Arc tangent, you're going to get a perfect 45. But we have that decimals way over there. The 42S does the same thing, but I think it carries the decimals out even farther. So now we're going to go arc tangent. Let's go arc tangent, and we have 45,0002. That's the decimal. And if you convert the decimal, when you convert, don't forget to find that convert in your 42S. It's that key 5. You make sure you hit the orange shift key. And this is your this is your angle here, 45, 0 minutes and 1 second. That's the difference there. Now, let me see, what was I wanting to show you on that? So now we're going to take this off. 142,001. Now you walk up to this triangle and you don't know what this is. This is what you're looking for right here. We're not worried about this yet. We just really want to concentrate on a point I want to make here. We have the angle and we have the side. We have the adjacent. This is angle, we'll call this one angle A. Let's call it B because that one's A, so we'll call this one little b. All right, lowercase b. All right, so we already have our angle in there. We don't have our opposite. Remember, one side or one angle will give us the solution. So our digital angle is 45.002, and that needs to be stored. I'll store that as 0. And let me see what it show. Yeah, that shows, if you go with that, it shows 45.0020. They round up. Okay. So I have that angle. Now I'm going to hit tangent. And let's see here, what we have is, okay, that's not what I'm, yes, that is what I'm looking for. All right, we're going to do this the other way too. So now it says 1 again, so it's just the opposite. So now we would go 1, and now you want to go show, and you're seeing that it's greater than 1. If it's greater than 1, that means this side has to be longer than this side. If it's 45 degrees or greater, this arc is 45 degrees or greater, the opposite side is going to be greater than the adjacent side. In this case, it's only 1,000th greater, but it's greater. So that's how you know. So this is easy because 3, 4, 5, you know what you're doing here. This is way you're going to get a triangle, and if you can't figure out which way to go, this is your clue. If it's 45 degrees greater or 45 degrees or greater, well, 45 degrees, it has to be greater, because if it's just 45, it's going to be 1-to-1 ratio. So it's 45 degrees, so that's how you do that. And now we're going to go 142 times, and it gives 142.001, which is what we have. The main thing is to be able to really pay attention to those angles there. Now, if that was less than 45, we'll try it. Let's try it this way. Let's try it backwards. We'll try this 40. Okay. Now we're going to go with 142. There it is. Let's try it this way. I'm going to pull out the angle. Recall 0, 145.002 is right there. We want the tangent, and that's 1. Now let's look at this, the show, and it's greater. It's that same tangent, so it's greater. Yeah, so it's great. So we know this is longer than this side. It has to be because the angle is bigger than 45. So now we know to inverse it, to 1x it. Okay, so I 1x it, it still says 100, so let's go to show. And now it's showing 999999999. Okay. So now we're going to go 142.001 and then times. And we have 142. Right where we started. So that's where we started. So the main thing to get in your mind on this is the angle. They both said 1. They both said what looked like 1 ratio. If you can't look at your decimals, but you know you have it here, you got to be able to look at your decimals where it carries out, then you'll know that this line, just looking at the angle, you're going to know that this line, this side is longer than this side, just because the angle is greater than 45. All right, that's it. That's all they needed to tell you on that one. And over here, we're talking about these calculators and how they convert from digital or from decimal to hours, minutes, seconds, and back and forth. And so you got to get handy at that. So the other way is the longhand version. So let's go over here. I guess I got to get over here out of the way. You don't need to see me anyways. So we're going to take this angle here, 36, 52, 12. Now we're going to start with HMS, hours, minutes, seconds, and HR. And I'm using the same terminology that the 42S uses when you do that conversion, that line when you select back and forth. I guess this must mean it's not digital or it's not decimal degrees. I guess it's hour decimal hours. Not sure what that stands for, but that's the terminology they go for. And on this one, they just got HMS blue, HMS amber or orange color going that way. Not quite as clear cut. All right, and so on, but you look for that on your whatever calculator you decide you're going to use. So our angle, and the reason I'm starting out with, oh, I used the wrong color. The reason I started out with the HMS, the hours and minutes second, I'll go ahead and use the blue, degrees, minutes, seconds. That's how they're usually written on the maps, on the civil engineering maps, on the plat maps, on azimuth bearings, on topographic maps. They're giving you that. They don't give you the digital. The digital is for the mathematics to manipulate. So we're going to do that. So how do we convert this to digital? What is our data collector doing? Just like the data collector helps us figure out the calculator helps us figure out what the survey data collectors do. This little math problem is going to help us figure out what this is doing when it's converting. All right. We're converting 36, 52, 12. First thing to keep in mind, I'll change my pencils here, my pens, is just hold this. You don't need to mess with the degree. I think I was telling you yesterday too, if you are getting your graph paper out and your scales and your protractor and you're practicing these angles, put in 2 angles and mess with all the stuff you've been learning and practice, you can leave the minutes and seconds off for a while. You're not going to get that accurate with a protractor anyways, or a scale. So just leave those off and until you get just where you're using the calculator and the paper and you kind of rough it in. It just makes it easier. But once we get going, we're going to want to definitely use minutes and seconds and get used to converting back and forth. Because as I said yesterday, when you start taking the test, you want to be very conversant at it. You want to be quick and don't miss out on any steps, because you will mess up on your answers on that if you forget to convert. All right. So we got the angle is 36 degrees, 52 minutes, 12 seconds. So we're going to start. We should go from this to decimal, and then we're going to go from decimal back to hours, minutes, seconds. So on this one, now this is a formula. You can find it in the book, or you can write it down here, take a screenshot, write it down, put it in your notepad, because you're going to have to remember it, and you can't not just read this and go through this, but I'll give you a kind of a walkthrough of it, but make sure you write these formulas down or find them somewhere else. All right, so we're going to start from this direction. We're going to start with the seconds, 12 seconds. So we go 12 over 60, because there's 60 seconds in a minute. So that equals 0.20. So there's 0.20 seconds in a minute. Now you're going to bring your minutes down, 52. You don't need decimals here. You didn't need them here either, just 12 over 60. Now we're going to bring our minutes down here, 52 minutes plus 0.20 minutes equals 52.20 minutes. And you divide that by 60. Now you're dividing that by 60. and now you're getting 0.8700. That's your decimal. So now you're bringing your 36 down, adding it to it. Your decimal is 36.8700. All right, now we're going to just, that's this angle here. You can see we've already, well, it's rounded up to 87, 86.99. Keep in mind, when you're doing this, you're going to have some leftovers past the 4 decimals. 1 second is 36, there's 3,600 seconds in 1 degree. So if you're throwing a second away, one way or the other of your equation, not a big deal. We're not NASA. NASA, I think, carries their decimals out from here to the end of the road. That's how they can land those ships wherever they want, or the rocket ships, and get them up there in orbit and doing their stuff. But we don't have to do that, although we are very accurate survey. Okay, now the reverse of that is digital or decimal degree to hours, minutes, second. We've taken this number now. This is what we have, 36.8700. Now this time we want the decimal. We want the, and we're going to multiply. Multiply instead of divide. And we're going to multiply times the whole fraction there. So 8700 times 60 equals 52.20. Now what you want to do is you just keep that 52 over here, and you ignore the rest. Now you're going to go, the leftover on that is 0.200. Now you want 0.20 times 60 equals 12. And then you put those two together. 52.12, and bring your 36 down. 36.52.12 is right here. 36.52.12. Practice that. That's the formula. We'll do the same thing over here one more time. 225, 47, 32. We're going to take 32 divided by 60 is 0.533. Add that to the 47 over 60 is 0.7922. And now our decimal is, or decimal degree is 225.7922. And that's what we're starting from here now. 225.7922 times 60 equals 47, and that's the remainder. And then you add 5320, that's the remainder, 5320. You just keep those two left ones, 5320 times 60, 3192. Now this you might want to round up. Normally you just drop that, it'd be 31. But since it's 31.9, I went ahead and rounded up. And that gives me 4732, 225, 4732. And what did we start at? 225, 4732. Okay, you got to practice at that. Just keep practicing. And I would, when I first learning this, I was just doing it and storing these numbers in my data collector and or my calculator and going back and forth. I would write it down. I would write the two angles down so that as you're figuring one out, you can keep looking at your paper. So that is today's lesson, and good luck. I hope things are pretty clear so far.